I want you to be at a stage where you are amazed and not frightened.
Yeah, that's exactly where I am right now. So that's perfect.
So hey everyone, welcome to yet another video. I'm really excited about this video because we have a very special guest, Mr. Kevin, and he is a real CSS guru for me. I love his videos on his channel. You can check that out. And he's over here because I'm going to challenge him, not about his CSS skills, but his problem solving and data structure algorithm skills, because this is what this channel is about. And if you want to watch the other video in which he challenges me and he brutally, defeats me in the CSS battle, like I really did not perform that good, but I was like kind of average, you can say, or a bit above average, you can say. So yeah, you can check that video on his channel. And Kevin, please, welcome to the channel and please introduce yourself to the audience once.
Yeah, first of all, just thank you so much for having me here. And yeah, I'm pretty much a CSS guy. It's what I've started, sort of made my name in, and I like showing people that CSS is, while it's different from other languages, it actually is a pretty good language. And as I say, I like to help people fall in love with it. And if I can't make them fall in love with it, at least be less frustrated by it. Because I know it can be really frustrating for people, but there is a logic behind it. It's just different from other languages, and I try and help show people that.
Awesome. So let's start with the algorithmic and problem solving skills. Let's see.
This is where CSS is problem solving. It's one of the reasons I love it. I think anything like this is, but this is definitely me, like you're throwing me in the deep end here. I don't know. This is not something I'm very comfortable with. I'm really like front of the front end. So we'll see how I do, but I'll probably need some help along the way.
Of course. And I'm like, the reason why I want to, I'm interested in this video is I'm sure that you will have fun and you will learn something while we reach the end. All right. So can you just share the screen? I have shared with you the link to the editor on which you will be working. All right. So this is the problem statement that I have for you. This is really fun problem statement. I really love asking this question even in interviews. I'm sure that you will have fun. Let's read the problem once.
So we want to implement a function, will first player win, that takes input as a number and returns whether the first player will win the game as per the below rules. In each turn, you can decrease the current number from 1 to 9. The player who makes the current number 0 wins the game. Each player plays optimally. So for example, if current number is 23, A subtracts 9, so then we go down to 23 minus 9, so we have 14. B subtracts 7, current number is 14 minus 7, so you get 7, and then A can subtract, so A wins. So yes, that makes sense. Okay.
So
I don't know how we're going to do it. I know what we want to do. I just don't know how to do it.
But do you want to do you want to play this game with me first?
Yeah, sure. Yeah.
All right. So let's go to index.js because we can do some
there we go.
We can simulate that kind of thing. So yeah, so do you want to play first? I think if I'm asking the question, I should give you the benefit of going first. So let's say our current number is, and why don't you decide what our current number is?
Let's not go too big. I don't know. Let's just say 31.
All right, 31. Okay. So let's say it's your turn. What do you want to subtract from 31?
So we'll do 31. I'll do minus 9.
All right. So you're going greedy, huh? You want to reach 0 as fast as possible, and you probably want to end this real quick, right? So this becomes 22, right?
Yep.
And now it's my turn. Let's see. Let's say I subtract something like 3. I'm not sure why, but yeah, I did subtract 3. Now it's 19. Your
19.
turn.
So then I want to do minus 9 again. Would be the best one for me, I think.
Okay. And then let's say I subtract 5 from 10. So this is again 5, and then you win, right?
Yeah.
All right. So I think you were really good at it, and you have already defeated me.
The first player definitely has the advantage.
Yep, I can see that. Do you want to play this again, or do you know how to solve this problem? Do you want to probably play again?
Yeah, let's do one more.
All right. What number do you want to start with? I think your confidence is better, so you can start with something.
Again, I don't want to go. Let's try the 45 this time.
All right. So you're still playing safe, huh? This is how I usually do investment. Even if I make profit, I don't just simply increase the principal amount. All right. So what do you want to like subtract from this?
Let's say we'll do -8.
-8. So this becomes 37.
Mm-hmm.
Then let's say I subtract. So I'm going to follow you. I subtract 8.
29. So then let's do, yeah, we can do -9.
Okay.
We can go big for now. We'll hurry things up a little bit.
Okay. So this becomes 20. I subtract
Mhm.
1.
19. So then I would subtract 9 again.
Damn it, man. You are doing really well. I see. Okay. So 19 minus 9 is 10. And then let's say I also follow you and I subtract 9 and then I lose, right?
Mhm.
All right. So yeah, you subtract 1 and you become the winner.
Yeah. So I think I know well, I know the strategy. Yeah, because I know
Okay.
one of the things you did mention is that the players play optimally. So it does
Yep.
mean that like you're not just randomly choosing any number.
Yeah.
Where I mean, for me, that's where it gets difficult, is figuring out how to get the computer to want to, like, ideally you get to 10. If you get to 10, you've won, because the other player can't win at that point, because it doesn't matter what they subtract.
Yep.
So it's all about trying to get to 10. So that's what, anyway, we'll see what we can do.
I mean, you are doing really well. You are, I mean, I actually didn't expect that this will turn out this way.
It's sort of,
do you feel
when
that
we,
the first player will always win? Do you feel like that? Like it's happening that way, I believe.
I think, I mean, not, I think I guess it's a lot harder for player 1 than player 2. Sorry, it's a lot harder for player 2.
Okay.
I think that maybe there's a way of, like, say you're trying to get, like, I'm trying to get to 10, but maybe there's, like, that also means if we're at 20, like when you're above 20, there's probably a way to like optimally get to there each time. So you probably have to play like a bit of a game. But I guess if you're like, I wasn't thinking of it at the beginning, I was only thinking of 10. So maybe I could have made a mistake along the way that would have forced me to, like, you know,
Yep.
maybe there's something
Everything
that
is
could
making
force
sense
you.
so far. Whatever you're saying is
Yeah.
making sense to me. It's just about writing. Like I think you can write the function or not.
I'm not sure if I can write the function. I could probably plan it out a little bit, but I don't know if I could write the function to make it work.
I think you can start with writing the function, and probably you can just add a comment like whoever reaches 10, like he's the real winner.
Yeah. Yeah, that's true. You wouldn't even have to evaluate it after that. Like, well, I mean, technically would, but you could just declare. Yeah, you could declare whoever's that.
Like, do you want to probably give it a few more a minute or two to probably think what's going on, because you are really very close.
Am I? I think I'm missing something that would just give me the final thing, but I can't think it through right now.
So what do you know so far?
So, well, we know we want to get.
Yep. Yeah. Let's just complete the sentence, because you're saying the right things.
So yeah, I know I want to get to 10, and I guess even if you're higher than that, you want to be at 20. Because if I was at, if we hit 20, then I know I can get to 10 no matter. I can force it to be at 10 or smaller depending on what you get to. But I don't know. I think I'm missing the right vocabulary here, maybe.
I mean, this is amazing, man. Like, you have really sharp mind.
Thank you. But it just means, so like, yeah, I don't know where to go from there.
Yeah. So basically, initially, so this is how I'll just basically repeat whatever you know. I'm not putting out anything extra information. I'm just restating whatever you have said so far. Okay. So initially we knew that whoever makes the 0 wins. Then we know that whoever makes the 10 wins, right? So now initially when we were trying to solve that, okay, if I need to make 0, we know that if we reach to 10, we can make a 0.
Right.
So now the problem becomes similar to how it was for 0. Now think from perspective of 10. How do you make a 10? Initially you were trying to make a 0, and you know that making 10 is the optimal answer. Now you want to make a 10. So what do you think is the next thing that you want to make?
So yeah, then it would be 20.
Yeah.
Yeah.
And why that works, and I'll probably chip in over here, is so just to explain what's happening. So the reason why 10 works is when you have a 10, and what we can subtract is something from 1 to 9, right? So if you make a 10, then this is something that we will get back, right? 10 minus x.
Mm-hmm.
And x is what the other player is going to subtract. So we made a 10 and it was the other player's choice. And the other player can subtract anything from this range to this range, right?
Yes, perfect.
Right? And they were having 10, and this is what we will get back. We get back 10 minus x, right?
Mm-hmm.
So now the thing is, if x is between 1 to 9, you can, if you want the mathematical proof, what you can say is -1 is greater than equal to -x, greater than equal to -9. All right. And then you can simply add 10 over here, 10 over here, and 10 over here. So this becomes 10 minus x is in between. So this becomes 10 minus 9 is 1, right?
Mm-hmm.
And 10 minus 1 is 9.
Mm-hmm.
So we get back 10 minus x, which is always a number between 1 to 9. So we can always subtract whatever we have over here to make it a 0.
Yep.
Does that make sense?
That makes perfect sense. Yeah.
Right. We know, we can see using math that whatever we get back will always be in between 1 to 9. And now the thing is, you were over here, right? Similarly, if you had a 20 over here, right? If you had a 20 over here, what you get back is 20 minus x, right? And 20 minus x would be in the range of, this is 19 over here, and this becomes 11, right?
Mm-hmm.
So now since you have 11 or 19, you can always subtract 1, 2, 3, 4 from it to make a 10. Right?
Yep.
So this is how it's working. Like if you make a 20, the other guy can never reach 10 because 20 and 10, the difference is 10. And unfortunately, the 9 is the max you can go. And no matter what they subtract, you can always make sure that, you subtract the other thing to reach the 10. That makes sense?
Yeah.
All right. So with this, like, do you want to start writing the function that we want to write?
Yes. I still don't know what to do, but yes.
All right. So you can go to the fungame.js file. That's where we have to implement this.
All right. So we want to say that we have you gave us a name, right? Will first player win is going to be equal to a function. So it's here, I guess. I mean, we need to pass a number here to start with. And then what do we want to do? So we need to so we want to, and then, okay, let me just think for a second. So will first player win? We give a number. So see, I guess we have to evaluate the number. We want to get, so what I don't know when I'm breaking it down, because I mean, this, when it comes to actually making it work, I don't think is my strong suit, but I'm not bad at breaking things down a little bit. And I did notice actually when we did the CSS stuff together, I liked watching how you were thinking about it, because you could really see like the programming side, like the logical side coming in and breaking down the problem before going in, which normally you don't see. So I like seeing that side of things. So we want to evaluate the numbers. We want to see what the number is. What I don't know is, like, we want to we want to get, like, say it's 45 versus 35 versus 25. It doesn't really matter. Like, that's what I don't know of how to say. Like, we want to get it to. I don't even know the terminology for that. Like the closest 10, I guess, right? Like,
the multiple of 10.
So I mean,
basically, if the first player is making 10, 20, 30, then you can say that he's going to win. Yeah.
So here, actually, I just want to hear, will first player win, and you give it a number.
Yeah.
So I mean, the first player should always be able to win as long as they play optimally, right?
Yeah. So both players are playing optimally.
Yeah.
And you are saying that the first player can always win because of the strategy that we have.
Yeah. So the first player should always be able to win. So here, like I could say, well, the first. So I mean, it will return true. I could put that in because I know the first player will win if they're playing optimally all the time.
Yeah.
But we still want it to run through everything. Sorry, I'm talking a lot because I don't know what to do.
That's actually a good sign, especially like when you are doing coding interviews, and like especially during COVID times when you can't actually. Sometimes you even are not on a video call, and you are just staring into a blank screen. You really don't know what's going on inside the head if the other person is thinking something. So yeah, it's really good that you are thinking out loud and you are thinking like everything is making sense so far. So yeah, keep going.
So we want to do like again, I don't know how to put it, like the closest 10. I just evaluate the number because even I might be skipping a step. We want to subtract subtract to get to closest 10.
Yep.
Does that make sense?
Makes sense. Yeah, it's making sense.
Once that happens, so I'm going to say player one. We'll just put player one. Subtract to get closest 10. Player two sort of stuck, but again, I mean, you just want to keep doing player two subtract. I mean, you're going to sort of loop through that for both players, right? Because the other player is trying to get there, even if player one's not letting them do it.
Yeah.
So you just want to loop through that as much as possible, and then
player two is also playing optimally. But like, let's say you gave me a 10. However optimal I play, however smart I am, I can't do anything, right?
Yeah, player two so subtract between 1 and 9 to get to the closest 10. I think that's important. Obviously. So same thing, subtract between 1 and 9 to. So in player two's case, I mean, it doesn't really matter because we can't get to. You might not be able to, and even here, well, I guess player one can always get there unless actually, if the number 30 is if you start with the number 30, aha,
exactly.
Yes, player two can win. We found player two can win to get to.
Amazing, man. Yeah.
Player one subtract between 1 and to get to. So we can't always get to it. So get as close to closest 10. That's really badly worded, but whatever. So player one, subtract between 1 and 9 to get as close to the closest 10 as possible. And then you just do the same thing. And then you just loop through that over and over again, pretty much.
And then whoever makes the 0 wins, right?
And then whoever gets 0 equals winner.
Yep.
If player one equals winner, return true. Right?
Yep.
That's sort of what we want to do. Okay.
Yeah. So like you have covered all the base cases, like all the corner and edgy cases that could have possibly gone wrong. Like this function can actually be one-liner and it can simply say return true, right?
Right.
But the thing is, if the initial number is itself a multiple of 10, something like that. Like if you're starting first and I say, hey, Kevin, the first number is 20. What do you want to subtract? You are screwed, right? You can't do anything now. And even if you go to as close, even if you try to go to as closest as possible to a multiple of 10, it doesn't matter. Because we both are playing optimally. The beauty of this question is that even though both players have to play optimally, it's actually always one player who will be playing optimally because the other person does not have a choice.
Yeah, exactly. Yeah.
So
because of that, it's really, you're just evaluating the number and then you return the true. Like you don't have to really worry about it. Like you don't actually have to do anything in the function for that. Yeah,
exactly. You don't have to do that. So basically, what you can actually say is that something like if number modulo 10 is 0. So what this does is the number a multiple of 10. So if that is the case, what do you think should happen? I think the second player will
if it's a multiple of 10, player 2 wins. Yeah.
Right. So we return false. Otherwise, we return true.
Yeah.
That's pretty much about it.
Return false. Whoops. We might as well finish it since we went through all of this. And then else return true.
Yep. that makes sense. And actually, I was also writing it, just taking a time.
Oh,
to sync
I
up.
didn't see it. Whoops.
I have deleted it. So yeah, it will sync in a while with your screen as well.
Okay. There we go. Yeah.
Cool. So
yeah, that's right. We don't even need the else statement. It's true.
Yeah, this is a very common pattern. Like if you're using if and you have something to return, especially when you are writing recursive functions. This is you generally have base cases in the starting, so you will have a return over there. And otherwise, just because a base case is there, and then everything is put in an indentation just because of having an else block. So yeah. It's better to do it this way.
Yeah.
Cool. I think you did really well. This was amazing. Do you want to do another problem?
Yeah, let's do it. It's
all right.
fun.
So this is why I really love such games. Okay, so let's do another game.
Perfect.
All right. So now think of another game that you and me are going to play. Now this time, like it's boring with like just playing with numbers, right? And just a single number. We don't have much choices. So let's say we have an array and we have a bunch of numbers in that. For example, we have 3, 2, and 5 and 5, for example. Okay. Now we are going to play a game on this number, and how this is going to work is, let's say again you go first. So Kevin goes first, and Richard goes second. Now the thing is, now we are going to play in each turn. One of us, like whoever turn it is, for example, it's my turn. What I'm going to see is, so we have this array. I'm going to look at the first number and the ending number, and I'm going to, you can say, eat that number, and I get that much score. Okay. So if I eat the 5 on this side, the array becomes 3 to 5, right? And Rachit eats 5, for example, right? So this is the remaining array, for example. And then Kevin can eat whatever you want. Like probably you can eat 5 again. So the array becomes 3, 2. Then Rachit can eat a 3. And then Kevin is left with the 2 and he eats that. So Kevin can eat 2 or he has to eat 2 because there is no other choice. And then the array is over.
Yep.
So if you will see, my total score becomes whatever I ate, which is 5 plus 3. So my score is 8. And your score is 5 plus 2, which is 7. So my score is bigger, and that's why I win, right? So basically, you have to write a function that takes argument as array, and you have to tell whether the first player can win or not. Again, both players are going to play optimally. So you have to write this function, for example, will first player win, and this is the array. So it has to return a true or false. So first of all, is the question clear?
Yes. The question's clear. How to do it is this one's a little trickier.
Yeah.
Because now before was easier because as soon as the first number was decided, we knew.
Yep.
Whereas this time, like here, I'm just trying to think, like it's almost like, because we're saying like to play optimally, no, that wouldn't either way in this case, it wouldn't matter. But I'm just thinking like, depending on the array, you could have different situations where maybe okay. I'm just trying to think. So yeah, you have to choose which side you're going to pick from. But then it should go pretty easily from there, I guess. It's just so let's just say, we'll type out what I'm saying. Will first player win, and you put in an array. So then player one picks high. See, I think there's already, but anyway, okay. So player one takes highest number. We want to remove that from array, and then we also want to add add to score. So at the beginning, everybody has a score of 0. Player 1 takes the highest number, remove from array, add to score, and then we do the same thing for player 2. Player 2 takes highest from array, highest number.
Highest from the end, right?
Array. Yeah. Oh yeah, that's right. Yeah. Player 1 takes highest number from either
end.
Yeah. From from either end, and then again we remove from array and add to their score.
Yep, perfect.
Add to their score, their score. And then at the end, when array is empty, we want to
compare the scores.
Yeah, compare scores
and declare the winner.
If player or declare winner, perfect. Declare winner.
Yep, I like how you make progress by writing small step by steps, the approach that, and it's making sense, to be honest. Like if I had no background with data structures, algorithms, and all those kind of things, this is the best that I could have also come up with. So yeah, this makes perfect sense. So you are basically saying that always go greedy, right? If I have 3 on one end and let's say 13 on other end, I'll pick 13 because 13 is bigger than 3, and I'm trying to maximize my score because that's what I'm trying to do. And as I've said, both players are trying to play optimally, right? So the thing is, however, like this makes sense, but what do you think will happen with this approach if we have something like, if the array is 10 and let's say on the other end we have 5, and over here we can have anything, right? So what you are saying is, if you are playing first, you will take this 10, right? Because 5 is smaller and you're trying to maximize your score, right?
Right, that's what I said, yeah.
So now the thing is, if we have, let's say, 1,000 over here, right? And then a 1 over here. So now what do you think will happen?
Yeah, so then if you take the 10, you lost.
Because Kevin is taking 10, then Rachit will like very happily take 1,000, because I'm following your strategy. I compare 1,000 and 5. I say that, okay, 1,000 is better, and I take that. And then you can take a 5, but I took these two numbers. I ate I think 1,001, and you are having 15. So yeah. However, if you took 5, then I am forced to reveal that 1,000 for you in the next turn, right?
Yeah.
So so 5 is smaller, but taking that is benefiting you.
Right. Yes, exactly.
So imagine that you have some magic function. Okay. Let's say it already exists for you. You pass in the array, and it does not tell you whether the first player win, but it does even more. What it does is it tells you exactly by best possible margin the first player can win. Does that make sense? Like, it's a magic function. Let's say you already have this implemented and you have enough trust on this function. And what it is saying is, it tells you exactly by the best possible margin the first player can win if they are playing on this array. So if, for example, if you want the magic value for this function, the answer would be, so we can see that taking 5 was beneficial for you. So Kevin took 5, right? And then I will take 10, because no matter what I take, 10 or 1,000 is getting exposed, and I am playing optimally. So it makes sense to take a 10 for me. And then you will take 1,000, and I have to take 1, and it's over. So my score was 11, your score was 1,005, right? And you played first, so the magic function will return 1,005 minus 11. Okay.
Yep.
So this becomes let's see, 994.
9. Yeah.
Okay. So this is what this magic function returns.
Yep.
So magic of this is same as 994. Okay. So here's the thing. If we were having something like, what do you think will be the magic value for let's say 10, 100, 5? What do you think will be the magic value for this?
Good question. So it's always doing a margin. So I would have to choose 10, and then it would be 100, and then I would choose the 5.
Yep. So you choose.
So player 2, 1. Yeah. So I have 15. You have 100. Right. So it's going to return a negative number then. It's return 85. Yeah. Negative 85. Yeah.
Exactly. So can I say that over here in will first player win? Can I say that if the magic of this array is greater than 0, Oops, it should be like this. So can I say that the first player will always win because the margin is positive?
Yes.
So I can say return true, right?
Mm-hmm.
And if it's 0, I can say it's a draw.
Yep.
Right? That makes sense?
Yep. Yep.
So basically, it's better to actually store this value instead of calling it again and again, probably. Const margin of winning. So margin of win, you have something like that. And if your margin of win is, so can you just complete this?
It's not updating on mine. I'm just going to wait a second to see.
Okay. Oh, I think they are having debounce. I think they are having debounce because I was typing non-stop. So yeah, in line 14, 15, 16.
Oh, there we go. It just updated.
Yeah.
Okay.
Yeah.
Margin of win is equal. So kind of So then if margin of win is return true, then it would be if margin of win is equal to 0.
And it should be double equal to.
Oh yeah, sorry. Thank you. Equal. There we go.
0. I'm really happy that I'm able to make these corrections.
Yeah.
Like the CSS video was like
return draw. I guess. Can I return a string like that?
Yeah, we can. In JavaScript, you can return anything you want. That's the beauty of it. Like
beauty
it doesn't
of JavaScript.
care.
Margin of win is less than 0. Return false.
Yeah. So yeah, we can actually also return false in line 16 because
we don't.
The function
everything else is done. Yes, just like before. Oh, return false. That's true. Yeah. So I mean, that means if that's the case, and this is return false, and that's
we can actually do a console.log if you want that it's a draw. You know, just to differentiate that case.
You could do a But if both of these are returning false, could we just say otherwise, like return false? Right. Yeah.
True. Yep, this makes sense. So, like you have already solved this problem. I just want you to implement the magic function now.
See, the problem. This is, as you said, it's a magic function. So,
but I just want to make sure. Is it making sense? Like line 13 to 17. All right.
13 to 17 makes perfect sense to me. Yeah.
All right. So let's see what this magic function is doing. Can I say that there are only 2 choices that you always have?
Yes.
You don't have any other third choice, right? You always have 2 choices. You either pick.
You always have You always have 2 choices. Yeah. You either take from the first value or the last value within the array.
All right. So let's say I pick the number from the first, or let's say from the left. Okay. So if so, one strategy is pick from left or eat from left, and the other strategy is eat from right. Can I say that these are the only 2 options that you have? Okay. Now the thing is, if I'm eating from left, I get something, right? I get the left number. That score is getting added to mine, and then it's the other player's turn, right?
Yep.
Because I have played my turn, right? Now it's other player's turn.
Yes.
So if our function was something like array, can I say that what I ate is something like this, and probably I'm just using destructuring. Just bear with me for a moment.
Yep.
So yeah, basically what this does is the first element or the leftmost element will get stored over here, and rest will become an array. Okay. So does this make sense? For example, if the array was 3 to 1, then left is 3 and rest is an array with 2 and 1.
Yep.
Cool. So now can I say that magic rest will give me by how much the other player will win now? It will give me the margin of how much the other player can win. So if magic of rest is, for example, if this is, for example, 10, right? And let's say left is 11. So I took this tone and the magic of rest is 10. So can I say that I still win? Because this is like he was winning by 10, but then I also got a 11, right? In this turn. So I win by 1.
Yep.
Can I say that I win by 1?
Yes. I think so. Yes.
Yep.
Yeah.
Because I got 11 and the other player won by 10. So essentially I still won by 1.
Yes. That makes sense. Yeah. Yes. Because that makes sense. Because from the very beginning, we're always assuming both players are playing optimally. Yeah.
Exactly. Yeah. So had it been that the left number is 5 and this is 10.
Then you would lose. Yeah.
So then I will lose by 5 minus 10, which is -5.
Yeah.
Right.
Yeah.
So this is one choice. All right. So I've not made a decision. I'm just evaluating my options. That's fine. Similarly, if I can do the similar thing for the right side, right? So I get the right number, that is _pop, right? And then the remaining is actually, this changes the array. Okay, it's not on your screen.
It'll show up in a second.
Yeah, so I'm doing add.pop, so that will give me the last element, and I store that to the right. Okay, and I'm modifying my array also.
Yeah, I see it now,
yeah. Yeah. So basically now the rightmost element is stored in right, and then the array has been modified. Okay. So I can say that now you can say the rest that I'm going to give to the other guy is same, this array, because this pop function actually modifies the array. Okay. Yep. So now let's do the same thing, right? Again, magic rest can be, now this time it can be something like 9, and the right element can be something like 100. So can I say that you are winning by 91?
Yeah.
This makes sense? So given these two choices, now can you make a decision whether you should eat from left or eat from right?
Yes.
You can, right?
Yeah. So yeah, we'd want to eat, because the margin of victory is bigger. You choose whichever one has the bigger margin of victory, and then you go with that one. Yeah. Exactly.
So and just to make sure that we are solving this correctly, it could have happened that this is right was 3 and the magic of rest was 9. So this means that you are taking 3 from the right, and for the remaining side, the other player is going to win by 9. So eventually you are going to lose by -6, right? Or you can say you win by -6, which is same as losing by 6. Right? But now again, it's important like which choice you make. And the optimal one would be to actually lose from 5 instead of losing from 6. Does that make sense?
Yep. Yes. Yep. That makes sense.
Awesome. So what you can do is something like, so you can say const one option is in the left scenario. It is something like you got left and this is your margin of victory. Right? This makes sense?
Yep.
And then you can say the other option is you pick the right number and then again you use the magic. So it's a recursive function, right?
Yep.
So yeah. So this is what you have, and now you can say that return whatever is bigger, right? So I think in JavaScript you have number.max. I'm not sure. I'll have to check. One option.
Oh, mine, I just got disconnected. There we go. Okay.
All right. So as I'm saying, you can do number.max, one option, and the other option to actually make a very well-informed decision now. Because, as you were saying, we don't know, like if you just compare something, like as I was saying initially, right? If I have a 5 over here and I have something over here, I have 10 over here, right? If you'll just go up, here on line 9.
Yeah. Yes.
At this point of time, I can't say whether picking 10 or 5 is good. I need to understand what do we have over here. And that's why this recursive call of, this magic rest over here and here, this is helping us understand or process that information and come back with some values, and then we can make the informed decision, right?
Yep.
So this is exactly like how the recursion works. And like this is the main, like this is how you can complete this magic function. I hope this makes sense so far.
Yeah, it's awesome. Yeah.
All right. So now you can do a bit of, few optimizations that I'm not going to do, but because, I just want to make sure that, because this is something like you might have not ever thought of functions like that, like how you can use them to, do so powerful things. So yeah, I'll just leave it up to here. I want you to be at a stage where you are amazed and not frightened.
Yeah, that's exactly where I am right now. So that's perfect.
All right. So yeah, was it fun? What do you feel? Any comments?
Yeah, I know, a lot of fun. I love stuff like this. Again, it's really out of my wheelhouse. So just again, like the problem solving side of things for me is a lot of fun. I love breaking down the problem and trying to find the solution to it. And I know when I first started learning JavaScript, like I was pretty bad at that side of things. And then so it was a skill that I got. Once I started figuring out like, okay, I need to do something, like it was definitely a skill I had to build up of breaking down as much as possible. But my issue now, because I don't write much on that side of things, is knowing, I can sort of break down the logic, but then I don't know how to implement it. And so seeing how it can be implemented. And this is also, I think for me, something that is difficult is like, as you said, you can even like for me looking at this, I wouldn't have even thought of that solution, even though seeing it now, I'm like, yes, I get it. But then you're saying like, we can optimize this even more. And I'm just like, wow, okay. Like that's, like, so definitely it's a bit of a like diving that deep into things. Like it just, it amazes me that people can think of this stuff and get it to work properly.
It's like just about, like how it works with CSS. You kind of do certain things and certain approaches work. Like if I have to give you like just center a div, Kevin, you will be like turning, like you can shut down your noise and you can still do it, right? Like how the flex can be used to do this. So similarly, you have some approaches to approach such problems when it comes to coding interviews. And as I'm saying, like I had been doing this for 8 years, so I've kind of built some kind of expertise on this. But that actually allows me to also basically do this live streams, like in which I don't know what problem I'm going to solve, but somehow, because sometimes it can really get bad and I'm not able to, like understand why my approach is not working or why is it having bugs. Like you were choosing the greedy one in which it was not working, right? So yeah, that stuff also sometimes happen. But I love to do such live streams, and that's how you get actually better at it. Like
100%,
doing these things again and again.
Yeah.
All right. I really had lots of fun with you, Kevin, and thanks for being on the channel. Again, guys, if you want CSS content, just go to his channel. You won't be disappointed.
Thank you so much. And yeah, this was fantastic. Thank you so much for having me. I really enjoyed this.
All right. Thank you.